Next question is minimize z equal to 1.5 x plus y subject to the conditions are x plus y greater than or equal to 8, 3x plus 5y less than or equal to 15, x greater than or equal to 0, y greater than or equal to 0. We'll quickly go to plotting the graph again. And the first line is A, 8, 0, B, 0, 8, x plus y is equal to 8. Okay, A 0, 8, 0, B 0, 8, x plus y is equal to 8. For that, the solution side is non-origin side. And if you see the second inequality, you put x and y as 0, get 0 less than 15. The solution side is 0 less than 15 is true. So origin side, right? For that, the intercept is 5. This is 4. So we have 5 here. C 5, 0 and D 0, 3. So we have 4 here. D is 0, 3. Okay, for this the solution is going to be origin side. Origin side, this is going to be origin side, this side, right? And this is going to be non-origin side. Now there is no intersection at all. There is no common region between these two inequalities in first place. And if there is no common region, there is not going to be point satisfying all the inequalities simultaneously. And therefore, no feasible region, no common points. We don't know where the value is going to be minimum, where the value is going to be maximum. So this problem is not solvable. There is no feasible region at all, right? So problem is not solvable since no common points, no common region for all the inequalities. Not solvable since no feasible region, that is, there is no feasible region. The problem is not solvable since there is no feasible region. Okay, so we are quickly moving to, very easy this problem was. We are moving to the next example. The next example is maximize z equal to x plus y subject to so and so are the conditions. X plus y is less than equal to 10, x less than equal to 6. Okay, so we are going to plot the graph. The x-axis y equal to 0. We have y-axis x equal to 0. Right? Okay, first is 10, 0, 0, 10. So we have A 10, 0, B 0, 10. The solution side is of course origin side. So obviously it is origin side. The next intercept you will get after dividing by 15. The x-intercept is going to be 5. X-intercept is going to be at the midpoint here 5. So we have 5, 0 for the second line. The first line is x plus y equal to 10. The second line is 5, 0. And if you divide by 15, I get 7.5, but this time it is going to be negative 7.5. Okay, so this is going to be minus 5. Below there we are going to take it as minus 10. So somewhere between that will be minus 7.5. So D is 0, minus 7.5. We get the second equation. We get the second equation like this. So C is 5, 0. D is 0, minus 7.5. Then we, before plotting x less than or equal to 6, I would like to find the solution for 3x minus 2y equal to 15 and x plus y equal to 10, because then only I'll be able to tell x equal to 6 kahan pe aayega. Now x equal to 6 will pass from here, or x equal to 6 will pass from here. We will not be able to find out until unless we find out this point of intersection. For that, obviously, you'll have to solve them simultaneously. To solve it simultaneously, we have 3x minus 2y equal to 15. Then we multiply by 2 to this. We get 2x plus 2y equal to 20. And when we add these two, I get 5x as 35. 5x is 35. So in that, x is going to be 7. X is 7, y is 3. Yes, this point here is going to be P7, 3. Okay, so I'm very sure now that x equal to 6 is going to pass through the midpoint of 5 and 7. That is, x equal to 6 is going to pass right from the middle of these 2 points. Bisecting them, x equal to 6 is passing through the middle. Okay, x less than equal to 6 means it is origin side. Okay, so we have now for this origin side, for this origin side, for this line also it is origin side, and we have to restrict our solution to first quadrant. So this is the feasible region. We are going to get 1, 2, 3, 4 and 5, a 5-sided polygon, pentagon. Okay, right? So let us name the unknown points here. This point here we can call it as Q. Q will be x equal to 6, x equal to 6 intersecting with x plus y equal to 10 here. So by putting x as 6, you're going to get y as 4. Okay, when you're putting x as 6 here, in this, if you're putting x as 6, we get 18, because x as 6 is going to intersect with this line 3x minus 2y equal to 15. So when I put x as 6, it is going to be 18 minus 15 as 3, y is 3 by 2. So we are going to get r 6, 3 by 2. Okay, 6, 3 by 2, 6, 4, q r हो गया है. Q is 6, 4, R is 6, 3 by 2, C is 5, 0, O is 0, 0, obviously B is 0, 10. Okay, now this is the feasible region. We are going to maximize the value of x plus y. There is hint in the objective function itself. Whenever you get such a question, there is always hint in the objective function. The coefficients are going to be proportional to one of the constraints, right? You can see the constraints x plus y equal to 10. So x plus y is 10, and the same x plus y is also z. So z will be 10 for those points lying on x plus y equal to 10. Now that is maximum or not the maximum value, it remains to be seen. Okay, so for that I'll have to find out the values of z everywhere. So value of z at origin will be 0. The value of z at C will be 5. Okay, the value of z at R will be 6 plus 1.5, that is 7.5. The value of z at Q will be 10. The value of z at B will be 10 again. At Q we are going to 10, definitely 6 plus 4 is 10. At B we are going to get 10 because 0 plus 10 is 10. In fact, at every point on this straight line, the sum of x coordinates plus y coordinates is going to be 10. And all these points, at all these points which are also the part of feasible region, z is 10. X plus y is definitely 10 for these points lying on the straight line. X plus y equal to 10. The sum of x coordinate plus y coordinate is going to be 10. Not only for Q, not only for B, for all these infinite points lying on this straight line, the sum of x coordinate plus y coordinate is going to be 10. And we are going to find out the value of z for different points on this feasible region. I will obviously find the values of z only at the corner points. You can randomly pick up a point from the feasible region and also find the value of z. You can randomly pick up any point from the feasible region. You can find the value of z. You'll get the value of z less than 10. You are not going to get 10. You're going to get 10 only on that straight line, and that is the maximum value in the sum. So we have been asked to maximize the value, to maximize z, and I got the maximum value of z as 10, but not at 1 point, not at 2 points. I'm getting that at infinite points on the segment QB. So what is the max? What is the final solution? Max value of z is 10 at infinite points on segment QB. Max value of z is 10 at infinite points on the segment QB. Okay, the hint is objective function matches with one of the constraints. Okay, but that does not mean that in all such problems where the objective function matches with the value of constraint, this is going to happen. It is not fixed. It is not always the case that when the objective function matches with one of the constraints, you'll get infinite solutions. Okay, so I get infinite solutions at every point on this segment. I get the value as 10. The next is word problem. This word problem is slightly difficult, so that's why I am trying to cover it in this video. Okay. So the word problem is we have to solve the problem. Unlike some of the problems you might have done in exercise 1 in homework, the problems were in exercise 1 in homework, the problems were based on just the formation of LPP. Here in this, you'll have to solve the LPP. See, they have asked how many belts of each type must be made. They have not asked us to form the LPP and just leave the problem. In exercise 1, the problems would end like formulate the LPP from the above word problem. In this, it will be formulate the LPP and then solve the LPP. Solve the linear programming problem, okay? So it is going to be 2 parts in the sum. So the question goes like this. Cottage industry makes belts of types B1 and B2. Profit is rupees 40 and 30 on each respectively. Each type of belt B1 requires twice. This line is very important. Each type of belt B1 requires twice as much time as a belt of type B2. It's a very important line. So what does that mean? That if B1 needs say 10 minutes for its production, B2 will need 5 minutes. Each type of each belt of type B1 requires twice the time required by belt of type B2. So if B2 is produced in 7 minutes, B1 is produced in 14 minutes. We don't know what exactly how much time is needed to produce B2. So if B2 is produced in 5 minutes, B1 will need 10 minutes. One belt of type B1 will require time double the time needed to produce the belt of type B2. If all these belts were of type B2, so we would stop the production of B1 and from the industry all the belts produced will be of type B2. B1 बंद, B1 की जगह पे भी B2 बनाना है और B2 जो बन रहा है वो तो बन ही रहा है, B1 बंद करके B2 बनाना है. Then the maximum belts, cottage industry would make maximum word आना चाहिए यहाँ पे of 100 belts per day. It is max 100 belts per day. So all these belts were of type B2. Then we would have made only 100 belts, maximum 100 belts per day. Supply of leather is sufficient for 80 belts only. 40 buckles of B1 is available, 70 buckles of B2 are available per day, max to max. So how many belts of each type must be made so that the profit is maximum? So first you will identify the decision making variables. The decision making variables will be obviously profit is dependent on what? On belt of type B1 and B2. So let X units of belt B1 and Y units of B2 be produced. Okay, so we have to maximize the profit. I am writing in short, maximize Z equal to, directly I'm writing the objective function 40x plus 30y. This statement is very important. Each type of belt B1 requires twice as much time as belt of type B2 needs. Okay, so understand that how that will be helpful for us to frame a constraint. So in certain time, for how much the company runs, say in a day we are working T1 hours and we are working for T2 hours on belt B1 and we are working for T2 hours on the belt of type B2. Okay, so here the production is happening for B1 belts, here the production is happening for B2 belts. Okay, let us assume in, I don't know how much belts are to be made, वो हम लोग को find करना है. How much belts are to be made so that the profit is maximum? That is the question. How many belts of each type, right? So I don't know how much belts are to be made, but assumption, if I am making per day, say 20 belts of type B1 and 50 belts of type B2, तो टोटल प्रोडक्शन हमारा हो रहा था अब तक 70. अंडरस्टैंड, अगर B1, if I am making B1 belts in time T1 hours is allocated to the production of belt of type B1. In a day, T2 hours is allocated for the production of belt of type B2. If in time T1 I see that there are 20 belts of type B1 produced, and in time T2 I see that there are 50 belts of type B2 produced in time T2. So I stop the production of B1. Okay, we stop the production of B1 and we are going to make only the belts of B2. तो उतने ही टाइम में how many belts of B2 will you make? The answer is double, 40. 40 types of belts of 40 belts of type B2, हाँ, B1 नहीं. B1 का कितना बन रहा था 20, लेकिन B1 को टाइम डबल लगता है. B1 requires twice the time that B2 requires, right? So in the same time, I would have made, if I stop the production of B1, I will make 40 belts of type B2 because B1 को double time लगता है. So in T1 hours, I would have produced 20 belts of type B1. In the same amount of time, I can make 40 belts of type B2. एक बेल्ट B1 का बनाते हैं तो उसमें दो बेल्ट B2 के बन जाते हैं. दैट इज व्हाट द स्टेटमेंट सेज. एक बेल्ट B1 का बनाओ और उतने ही टाइम में आप दो बेल्ट B2 का बना सकते हो. Because time required for the production of one belt of type B1 is twice the time required for the belt of type B2. I again repeat this scenario. In T1 hours, in T2 hours, there is no connection in the number of belts of B1 and B2. They are independent. अगर इसके 50 बेल्ट बनते हैं, 50 बेल्ट ऑफ टाइप B2 और इसके 15 ही बनाते हैं हम लोग, there is no connection, as I said. Independent है. 15 belts of type B1 are produced in time T1 hours, and then 50 belts of type B2 are produced in time T2 hours, and suddenly we decide कि नहीं, अभी हम लोग को production इसका बंद करना है. We are going to stop the production of B1 belts, and in that time which is now available, which is now available in the day for us, we are not going to relax. We are going to make belts of type B2. How many belts you will make of type B2 in the same time? So earlier I was making 15. अब B2 बनाने लगूंगा तो 15 की जगह पे कितना बनेगा? 30 बनेगा. टोटल बेल्ट्स 80 बनेगा. पहले 65 बनता था. 15 की जगह पे 30 B2 का बनेगा. राइट? तो पहले 15 B1 का था, 50 B2 का था. अभी प्रोडक्शन बंद करने के बाद तभी 65 बेल्ट्स बनता था. B1 का प्रोडक्शन बंद किया बिकॉज ज़्यादा टाइम कंज्यूमिंग है. तो उतने टाइम में मैं B2 कितना बना लूंगा? 30. तो अभी मेरा प्रोडक्शन लिमिट बढ़ गया. आई हैव 80 बेल्ट्स ऑफ टाइप B2 नाउ. राइट? सो obviously the ideal thing is to stop the production of B1 because it is time consuming, and instead you make the production you produce only the belts of the type B2 and sell it in the market. You will get profit, but the problem is B1 का profit 40 rupees है, B2 का profit 30 है, तो थोड़ा 10 rupees वहाँ पे कम मिलेगा. and the second problem is उतना demand होना चाहिए of type of belt of type B2. खाली B2 का डिमांड नहीं है, B1 एंड B2 दोनों का डिमांड है. सो प्रोडक्शन दोनों का करना पड़ेगा. बट अगर खाली B2 का प्रोडक्शन करते तो ज्यादा बेल्ट्स बना पाते. दैट इज व्हाट द आइडिया इज. दैट इज व्हाट दैट स्टेटमेंट मीन. आई होप यू आर अंडरस्टैंडिंग द स्टेटमेंट मीनिंग. ओके, नाउ दैट विल हेल्प अस टू फॉर्म द नेक्स्ट constraint, right? So if all belts, now that here comes the important part. If all these belts are of type B2, cottage industry would make 100 belts per day, maximum 100 belts per day. Okay, so understand, in T1 hours we are going to make X belts of B1, and in T2 hours in the remaining part of day we are going to make y belts of b to understand x and y are independent. उनका अपना अपना value है. जैसे यहाँ पे था 20 50, 20 became 40, 15 50, 15 became 30. So what will x belts if I stop producing x, if I stop producing b1 and in that time I start producing belts b2, belts of type b2, if I produce in the same time, what I'm going to get is double the number of belts, right? 20 का हो गया 40, 15 का हो गया 30, तो यहाँ पे x का क्या हो जाएगा 2x. So I was making x belts of type b1. Now I stop the production of b1. So in the same time, if I make b2 belts, it will be whatever the value of x is, उसका double. तो अगर 20 बेल्ट बनता था पहले, अभी 40 बनेगा. अगर 15 बेल्ट बनता था तो अभी 30 बनेगा. मुझे मालूम नहीं कितना बेल्ट बनने वाला है, मुझको तो वही फाइंड करना है फॉर मैक्सिमम प्रॉफिट. ओके, एंड व्हाट दे हैव सेड इज if all these belts right are of type B2, then cottage industry can make max 100 belts per day. So अभी B2 का ही है 2x B2 और y भी b2 का है, तो टोटल हम लोग को 2x प्लस y मैक्स टू मैक्स कितना मिलेगा 100. इट्स वेरी वेरी इंपॉर्टेंट प्रॉब्लम, राइट? इट्स अ बिट tricky to understand, but I hope after this explanation you'll understand that constraint, how it arrived. So we have 2x plus y less than or equal to 100. 2x is, earlier it was x belts of type b1, y belts of type b2. Then we stopped the production of belts of type b1 and said नहीं, अभी इसमें b2 बनेगा. इतने amount of time में हम लोग कितना belts of b2 बना पाएंगे, double 2x b2 belts. So 2x plus y, फिर भी max to max कितना बना पाएंगे 100. Okay. Now the remaining constraints are very straightforward, pretty straightforward, right? So remaining constraints, let us solve that. It will be very easy. Okay, so यहाँ तक हो गया हमारा 100 belts per day. Supply of leather is sufficient only for 80 belts. So the earlier constraints were 2x plus y less than or equal to 100. Then we have x plus y less than or equal to 80. The supply of leather is sufficient only for 80 belts, both types included. At most 40 buckles for B1. So x is less than or equal to 40 and 70 at the most, max to max. It's not at least. Max to max there are 40 buckles for B1 available and 70 buckles for B2 available. How many belts of each type must be made for the profit to be maximum? Okay, now there has to be non-negativity constraint. X is greater than equal to 0, y is greater than or equal to 0. Since the cannot be negative, the belts production cannot be negative. I repeat the constraints. If all the belts of type B2 are produced, so 2x plus y is total number of belts B2. By stopping the production of B1, we get 2x amount of B2 and 2x plus y cannot exceed 100. Then supply of leather is sufficient only for 80 belts, both the types included. So max to max production x and y you take into consideration, then it is 80. X is the number of belts of type B1 produced. If we stop that production, then it is 2x. Otherwise, it is x only. If we stop that production of B1, then y B2 का कितना belts बनेगा 2x belts बनेगा. Okay, x plus y less than or equal to 80. X is less than or equal to 40. So कितना है maximum B1 का बक्कल 40. B2 का बक्कल maximum कितना है 70. X greater than equal to 0. Y greater than equal to 0. Non-negativity constraints. And I'll write Z here. We have to maximize the profit 40x plus 30y. So this is the objective function. maximizing z subject to the constraints. Okay, only first constraint we had to understand properly. Rest is easy. At most means max to max 40. At most means max to max 40 for b1, max to max 70 for b2. Now let us quickly plot the graph and get the solution, get the maximum value out. Okay, and we'll have to find out how many values of x, what is the value of x and what is the value of y. Okay. Yes, so let us start quickly. Okay, 2x plus y is less than or equal to 100. So we have 50 and 100. Okay, I should take then in that case scale. 1 centimeter is 10 units. Okay, on both the axes. 1 centimeter is 10 units on both the axes. So we have 10 like that, 20, 30, 40, 50, 60, 70, 80, 90, 100. Again 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. So first, if we divide by 100, we get 50 and 100. So 20, 30, 40, 50. So we have A as 50, 0, 30, 40, 50, 60, 70, 80, 90, 100. So we have B as 0, 100. Okay. So this is the first equation. 2x plus y less than equal to 100. Okay. The next is x plus y equal to 80. 60, 70, 80. So we have C 80, 0. We have D 0, 80. So we have C 80, 0. We have D 0, 80. CD is the second line. Okay. CD is the second line with x plus y equal to 80. If we solve these two equations, 2x plus y equal to 100 and x plus y equal to 80 simultaneously, we get x as 20. Right? We get x as 20 and we get y as 60. If we solve the two equations, x plus y is 80 and 2x plus y is 100, we get x as, subtract कर देंगे सीधा, x is 20 and y is 60. (20, 60). Now x is 40, straight line. Okay, x is 40. So I have I made AB, CD, then I can say this is E 40, 0, right? This is x equal to 40. Intersecting here, no? We can put x as 40, we get 40, 20 as a point, 40, 20. Then we have y is 70. Y is 70 goes from here. Yes, this is y is 70 going straight. Y is 70. For y is 70, there is a point here. We can say that point is f 0, 70. D is here. F will be this point 0, 70. Okay, and all these indicate that they are going to go towards origin. So we have feasible region as this. origin side. This is the feasible region O, E. I can say this is Q, right? You can have R also here. O, E, Q, P, R. What will be R the value? You have to use Y is 70 for that. Y is 70, you need to put in this equation. 2x plus y equal to 100. Y is 70 and 2x plus y equal to 100. उसमें अगर y is 70 डाला, 70 goes there 30. We have x as 15. 15 comma 70. So this is the feasible region. O, E, Q, P, R, F. O, it's a hexagon, not a regular hexagon, but it is a hexagon, six-sided figure, right? O, E, E comes here, then we have Q, then we have P, then we have R, then we have F, right? O, E, Q, P, R, F. So what is obviously maximum value find करना हम लोग को 40x plus 30y का. So what is z at origin? 0. What is z at E? 40,0 वहां पे डालेंगे तो 1600. Put it here, 1600. For Q, ZQ, it is going to be 1600 plus 600. Because we are going to multiply that by 20, so 1600 plus 600 कितना हो जाएगा? 2200. We are checking the maximum value. For that we are checking the corner point ZP. Z at P, that is 20, 60. 20 वहाँ पे डालेंगे Z में यहाँ पे, तो हो जाएगा 800. 800 plus 1800 आ रहा है. So we are putting 20, we get 800 plus when we put 60, 60 into 30 is going to give us 1800. So 1800 आएगा and that will give me 2600. Okay, next which I have is R. So ZR. If I put 15 here, I get 600. 4 into 15 is 60. We get 600, and then we get 17. This is 2100. 17 to 30 is 2100, and that is going to give us 2700, our max value, right? Because ZD, the last point, there are 6 points we have, hexagon, ZD, the last point, if you put 80 into this 30, we are going to get 2400. So where is the maximum value? The maximum value is at R. Right? So what should be the final answer? The final answer is I will get maximum profit. Maximum profit is rupees 2700 when X, that is the types of belt B1. Now, X is the number of belts of type B1. Belts of type B1 कितना बनना चाहिए? खाली 15. And belts of type B2 कितना बनना चाहिए? 70 for the maximum profit. For the maximum profit, ये हो गया B1. Number of belts of type B1 should be 15. और ये हो गया B2. 70 होना चाहिए B2. 15 होना चाहिए B1. We will get the maximum profit, that is 2700. So that is the solution. Okay, this is the full solution for the problem. So we started from here, right? Understanding this was very difficult, but this statement has very is very important for the first constraint, 2x plus y less than or equal to 100. Rest all the constraints are easy. Okay.